Would it be 3 over 2xy to the power of 4?
Oh, okay. So, we've got to be really, really careful. When you have something in the bracket and it's being raised to a power, it means that everything is being raised to the power of 3. So that's the y cubed, the x, and also the 6.
Would it be 216x to the power of 3 y to the power of 9?
The top bit, yes.
So would the final answer be 54x to the power of 2 y to the power of 4?
Indeed, yes. Let's just go through that. So yeah, you've got the 6 which is being cubed, you've got the x which is being cubed, and the y cubed which is being cubed. 3 times 3 is 9. 4 divided by 4x y to the 5. 6 cubed is 216. X cubed y to the 9 divided by 4x y to the 5. 216 divided by 4 is 54. X cubed divided by x is x squared. And y to the power of 9 divided by y to the power of 5 is y to the power of 4. Yes. Okay. Next question. There are 3 parts to it, so I'm just going to split it. So this is the main part, the main stem. And then there's part A and then part B.
Would A be A add 1?
Not quite. What you need to do is think about what 3 to the power of x plus 1 means. So what index law has been used there is one way you can think about it. Like what calculation using indices could have been done to get to 3 to the power of x plus 1?
3 to the power of x add 3? Or
Uh,
times 3?
why is it times 3?
Because when you are multiplying two of the same numbers with a different power,
Mm-hmm.
you add the powers.
Add the powers. So here they've added the powers. So in reverse, yes, 3 to the power of x multiplied by 3 to the power of 1. So then what does that mean if you had to do it in terms of a? What does that mean?
You make the subject A.
Well, not makes the subject a, but if we've got that this is equal to 3 to the power of x multiplied by 3 to the power of 1, what was 3 to the power of x equal to in the question?
Um, could you repeat that?
If you have 3 to the power of x plus 1 is the same thing as 3 to the power of x times 3 to the power of 1, what can we replace 3 to the power of x with?
A.
Yeah, because it is a. So we have a multiplied by 3. And what's that? What does that simplify to?
3A.
That's it. So expressing 3 to the power of x plus 1 in terms of a means it's 3a. Does that make sense?
Yeah.
Cool. So yeah, similar kind of idea for part B. Let's look at it.
Would it be AB?
Why is that?
Because 3 to the power of x add y is the same as 3x times 3y,
3 to the power of x times 3 to the power of y, yep. So
which is AB.
indeed, because 3 to the power of x is a, 3 to the power of y is b. So therefore that becomes a b. Nice, you got it. And then 3 to the power of 2y, that last one.
Would it be b squared?
Okay, and how did you get that?
3 to the power of 2y is the same as 3y and then brackets, then after the brackets to the power of 2,
Okay.
and then 3y is the same as b, so b squared.
Nice. You got it. That's the understanding that we were looking for. Nice. Okay. Um, Next question on slide 3. This is actually looking a bit more similar now to what we were doing, what we were actually doing last week.
I don't understand the question.
Okay, so 125 to the power of x is equal to 25 to the power of x plus 5. So, looking at those both, 125 and 25, they are both powers of what number?
5.
Yes. So in particular, we can replace 125 with 5 cubed, like that. And the 25 can be replaced with 5 squared, like that. Does that help?
Yeah.
Okay.
Would x be 5?
Okay, how did you get that?
I simplified 5 to the power of 3 all to the power of x to 5 to the power of 3x,
Mm-hmm.
and then 5 squared all to the power of x add 5 to 5 to the power of 2x add 5.
Ooh, nearly. If you're doing 2 multiplied by x plus 5 entirely,
5 to the power of 2x add 10,
yes. And
and
then,
then 3x equals 2x add 10,
because you've got the powers that are different, but you've got the same base. So, yeah.
and then if I take away 2 from both sides, I get x equals 10.
Taking away 2x from both sides, yes. You get x equals 10. Lovely. Okay, I think I have another one for you to try. Yes, I do. On this next slide.
Would x be 10 over 3?
Let us check. So, how did you do it?
I changed 16 to the power of x to 4 squared all to the power of x.
Okay, 4 squared to the power of x.
Um, I kept 4 to the power of 10 minus x the same,
Mm-hmm.
and made 4 to the power of 2 all to the power of x to 4 to the power of 2x.
Yep, because you multiply the powers.
And then 2x equals 10 minus x.
Now you got the same base. You can say 2x equals 10 minus x.
I added x, which was 3x equals 10,
Mm-hmm.
so x equals 10 over 3.
Lovely. That's it. Very nice. And then next one.
I got to 9 to the power of 2x over 9 to the power of x add 1 equals 3 times square root of 3,
Okay.
but I'm not too sure what to do from there.
Given that you've got 3 on the right hand side, you probably want to change 9 to some sort of power of 3.
Would that be 3 to the power of 5x over 3 to the power of 3x add 1?
3 to the power of what, sorry?
5x.
How did you get 3 to the power of 5x?
Oh, 3 to the power of 4x
Uh-huh.
over 3 to the power of 2x add 1.
Remember, you're multiplying the power, all the powers together. So at the bottom, you change the 9 to 3 squared. That 2 gets multiplied by the entirety of x plus 1. Does that make sense?
I think so.
Okay. So just to write this out. So 81 is 3 to the power of 4. That's raised to the power of x. 9 to the power of x plus 1 Well, 9 can be written as 3 squared to the power of x plus 1, and that's equal to 3 root 3.
Would the bottom one be 3 to the power of 2x add 3?
No.
Add 2.
Yes, because it's just 2 times x and 2 times 1. For the top, we get 3 to the power of 4x. Bottom, 3 to the power of 2 times x is 2x. 2 times 1 is 2.
If I take away 2x, add 2 from 4x, would it be 3 to the power of 2x minus 2?
Very good. Yes, you took away both bits. Nicely done for remembering to do that. So, yeah, 4x take away the 2x, because we're dividing, we take away. 4x take away 2x is 2x, and then subtract 2. And that equals 3 root 3. Nice.
I'm not too sure how to get rid of 3. I think you're on mute.
Yes. We've got to go back to our laws of indices. So the 3 is fine, but it's that square root 3. Do you remember your laws of indices?
I think so, yeah.
Okay. So yeah, what's the index law, I guess?
Um, do you have to, I can't remember one for square roots.
Okay. Um let's see. So if I had the square root of, I mean, we'll tell you what the law is, but I want to see if you can figure out what it could be. So imagine if you have square root of 3 multiplied by square root of 3. What does that equal?
Square root of 9,
Which is equal to,
3.
okay, so it gives you itself 3. Or if you like, 3 to the power of 1. So what power, so if I had 3 to the power of something times 3 to the power of the same something, what power is going to give you 1?
3 to the power of 1 times 3 to the power of 1.
Remember, we're adding, the law works whereby we add the powers.
3 to the power of half.
It's going to have to be a half, because a half plus a half gives you 1. The square root of 3 is indeed equal to 3 to the power of a half. Does that help?
I think so.
Cool.
Would 3 times the root 3, would it be 3 to the power of 1.5?
Yes, it would. Because you've got the 1 plus the half. So 3 to the power of 2x minus 2 is equal to 3 to the power of 1, because that 3 is 3 to the power of 1, times 3 to the power of a half. Add those together. So 3 to the power of 2x minus 2 is 3 to the power of 1.5, or as an improper fraction, 3 over 2. Nice.
The x be 7 over 4.
So how did you do that?
I got 2x minus 2 equals 3 over 2.
Mm-hmm.
Then I multiplied the whole thing by 2, which gave me 4x minus 4 equals 3.
Okay, getting rid of the fraction. I like that. So times this left-hand side by 2, you get 4x minus 4. Times the right-hand side by 2, that equals 3. Uh-huh.
And then I added 4, which gave me 4x equals 7.
Mm-hmm.
So then x would equal 7 over 4.
Nice. Yeah. Very nice. Good stuff. Okay, so overall, how do you feel about that?
Um, It takes a bit of time, but I think I can do it.
Yeah, it does take some time. Again, I'll give you some resources to help you with practicing those and just getting better at spotting them. One other thing I wanted to check is when it comes to solving quadratic equations, do you remember how to do those? So we're going to look.